Hello, everybody. Welcome to In the Loop. This is a podcast by Texas Guadalupe. We are the University of Texas Hyperloop team. I am one of your co-hosts, Gavin Nader. I am the head of business, and I am a senior studying economics here at UT.
I'm your other co-host, David Spittler. I'm the head of engineering for Texas Guadalupe and currently pursuing my master's in mechanical engineering at UT. Today, we are joined by Josh Giegel, who is helping to lead one of the most exciting companies in the Hyperloop industry, Virgin Hyperloop. Josh has worked at many different rocket companies, from NASA to SpaceX and Virgin Galactic. He then went on to co-found Virgin Hyperloop and is currently their CTO. Josh, it's great to have you.
Thanks for having me, David and Gavin.
So I guess to get started, you're an engineer by trade, and I'm just kind of interested in how you got interested in technology and then how you arrived at SpaceX.
So I'm a son of a family of engineers. So my mom, my dad are both engineers. My wife, my sister, and my sister's husband are all engineers too. So you can see that there was a wide variety of choices available to me as terms of potential career paths. So yeah, it was just growing up in, a group where we would do, go on vacation, we would go to museums or like Oak Ridge National Lab or the Air and Space Museum or whatever it might be. And then just working on things with my dad in the garage and the like really kind of spawned a passion for just building things. And then, as much as my dad's a huge builder, I love building things too, but I also love the theory side of it because it's being able to predict kind of the future from your seat. So decided to go into engineering, and I was kind of deciding between physics and engineering, but engineering I fell in love with too fast. And then did my undergrad at Penn State University and then came out to grad school at Stanford. And in between those two, doing an internship, I think my junior year at NASA, where I actually ended up meeting my wife, I found one of the people I worked with said, hey, you should check out a company called SpaceX. And this was around 2007. And so when I was looking at either continuing on for my PhD or doing something else, went down, interviewed at SpaceX right before they had their first successful flight of Falcon 1, so the baby rocket, interviewed with Elon and everything. And then the next day I was back at Stanford talking to my thesis advisor about, the PhD, and told him that there's nothing I'd rather do less on this planet than what you just described. So ended up going down and working at SpaceX, and then from there to docking with the International Space Station for the first time. So I worked on the Merlin 1D engine, so the ones that land a vehicle, bunch of things on the Dragon spacecraft, microgravity fluids, and a whole host of other really fun projects there. And then that was a really good place to learn how to be an engineer, get way too much responsibility when you're way too young. So it was all good.
And you described like a certain buzz that attracted you to SpaceX. Can you elaborate like what that was? Was that just not wanting to do PhD, or is that?
No, I think the thing that Stanford did really well was when we went out for the recruiting trips, and like there were two other recruiting trips I went on. One was to Caltech, and the other was to MIT. And in those other ones, they has a huge focus on you to your professor. But at Stanford, it was about more like you to your peer. And when I kind of was asking why do they do that, why do they focus on that, it was more of like, you don't change the world with the professor, you change it with your peer. And that's kind of a powerful thought, is that, the companies, the great companies that have come out of Stanford have been, Hewlett Packard, Google, and they're not a professor and student, they're two students working together. And that kind of buzz of meeting like really, exceptionally intelligent people, being able to be excited about being the dumbest person in the room because of the quality of the rest of the people in the room. And then when you went to SpaceX, I felt the same thing. And it was a little bit more in my vibe, which was, I like the academics, I like the theory side of it, but I like theory and practice through engineering. And that was really you had that same group, but you had a group that was a little bit more bent on building. And so there was that, that vibe of you're going to get in with, at that time, there's about 200 engineers, and you're going to get in with 200 engineers and you're just going to go build something that people didn't think was possible. And it's really been interesting to watch how people thought, all we were going to do is fail. And we did fail at the beginning, right? But now they're, they have the lion's share of launch, and it's hard to imagine what like even a US technology industry would look like without SpaceX. So I was really fortunate to be part of building that company.
So, full transparency, I worked at SpaceX last summer. I'm going back this summer. I've gotten to talk to a lot of people who like worked at SpaceX and obviously decided to continue working there. I don't really get to ask people who've left why they got or why they chose to leave. What was that for you?
For me, it was about two things. One, it was the desire to eventually start something on my own, kind of that entrepreneurial bend. And, the natural progression of successful companies is to get bigger and to work more and take over more market share and do all of that. And so when you started and there's about 400, 500 people and you leave and there's about 2,500 people at the time, it's a different vibe than it used to be. And that's fine. That means the company is successful. The other thing was, I kind of got my fill of making rockets and wanted to do something more like terrestrial, so to speak, which is like, hey, I like space. I'll be watching just like everybody else when that first person sets foot on Mars. But at the end of the day, like I wanted to do something a little bit more, close that I could impact everything here. And I became pretty passionate about, engineering for sustainability. Like what is energy? What is the way that, that will power the earth? What's the way we can reduce emissions and things like that? And so I ended up getting an opportunity to go to a smaller company, lead the research and development group. And it was in a, kind of a green space. So waste heat to power, doing new power cycles and things like that with carbon dioxide. And it really gave me a chance to kind of grow in terms of how to think about, you can't just have a widget. You just can't have a great piece of technology. It's about how do you actually deploy it to the world. And I think, I've heard recently, one of my favorite expressions is the difference between vision and hallucination is execution. And this idea that it takes more than just a good idea. You have to be able to build it. You have to be able to execute on it. And that was really the opportunity, I think, to go and learn that, it was nothing against SpaceX. It was just like, I wanted something slightly different for myself, which gave me a lot of experience to come start this, which, this is a autonomous, electric, zero direct emissions, high speed, future form of mobility that also will be something that, has its impact on the environment and gives us something that we all want, which is faster travel, more seamless travel, and more time saved.
So after EchoGen, you went to Virgin Galactic for a brief amount of time.
A brief amount of time.
Can you talk about like the birth of Virgin Hyperloop and how you like decided to fully commit to that?
So I think that the one thing I liked about going to the small company was that it was small and we were doing some really innovative, first of its kind stuff. The thing I missed was I grew up in Pennsylvania. It was in Ohio, and the Ohio scene just doesn't have as much buzz as Los Angeles does, or even Austin does these days. And this view that when you feel that like kind of pressure, it's like, and it's pressure from like somebody, your friend's doing something, he's starting his own company, your other friend's doing this, your other friend's working on this, you feel like, oh boy, I better put the guitar down and I better go work on something to get this going. And so I think like that vibe I really missed about, California when I was in Ohio. So when we came back, I had started, it was Galactic at the time, but it was actually now Virgin Orbit. So there was a very small team, about 7 of us that were kind of at the beginning of Virgin Orbit. And like a week after I started there, like literally a week after I started there, one of the guys I worked with at SpaceX and a venture capitalist approached me about Hyperloop. And you're like conflicted, right? Because you're in that honeymoon phase of a new opportunity and you're like, excited. And I kind of realized that maybe it's a little bit of a career step back in a way to go back and work on rockets, just because I'd already done that. And it was almost like a safe choice. And then I started to see what the opportunities were for, transportation and what this idea, not the white paper as embodied. There were lots of technical issues with that, but the idea of new transportation was really exciting. Something that huge potential, something that'll be around long after we are, something that's never been really dreamed of and thought of. And the ability to like the naivete, maybe the arrogance to think that you could actually do it, decided like, yeah, I'm in. So a couple months went by, we were trying to square some things up. And then I just got too excited with the idea and just quit Virgin Galactic and ended up starting this on November 2nd of 2014. And just this idea of like, even if it falls on its face in 3 months, I'm going to learn a lot more than I was doing kind of the other job and be better off for it. And, 3 months has turned into 6 years and, all kinds of crazy things in between now and then. So it was the blessing of having a spouse who was like, yeah, go do it. And then, it was, it's been quite the ride since.
Yeah, definitely worked out. So I kind of have an interesting question. You went from building like a rocket engine to building a company. And I'm wondering if there's like any engineering principles that if there's any overlap there, any lessons that you can carry over like from engineering to the business.
I think there's engineers by nature are just really good problem solvers, right? And you look at building a business the same way you look at an engineering problem. What are your inputs? What are your constraints? What are your desired outputs? And you work through that in a different way. And I will say the thing that can be frustrating at times is that it's not black and white like physics is. It's like, hey, this has a specific answer, a range of specific answers. Whereas when you're dealing with humans, it's anything but that from time to time. But it's also become a little bit more of a challenge, which is you have less instant gratification like you do coding or seeing something that you work built, but you have more of almost like a paternal satisfaction when you see the team succeed, when you see an idea that you've sparked turn into something that's like a phenomenally better way of doing things. And so I think there's that aspect. I do think the other aspect that's been kind of oddly helpful in this has been the musical side of things, kind of in a strange way, which is, engineers too often, in my opinion, try to project intelligence at the expense of understanding, right? They want to show people how smart they are, and they don't care if they actually learn something. Whereas if you're like playing with other musicians, you know how to play music together. And if you don't play well with the other musicians, it sounds dissonant. It doesn't sound good, and it's awkward and all of these things. And so that knowledge of how to kind of interact and play with different people to get the best out of them to ultimately make the best kind of music, if you will, if you take that metaphor, then you're trying to learn how to read people. You're trying to learn how to take your ideas, communicate them to others, and have them buy in, which is a lot harder than just kind of doing it yourself. But it also gives you the ability to scale in a way that you could never do by yourself. Like there's no way I could ever build what we've built as a company by myself. Just like, anybody who's done anything amazing before, they need a team around them to do it. And I think communicating that, getting people on board with the vision, getting them excited about, the same things that you're excited about. And at the end of the day, like they look at you every single day and they're like, is this guy excited about what he's doing? And yeah, I mean, if there was 25 hours in a day, like I would be working on this 25 hours in a day. And it's the faster you can do it, the faster we can all realize it.
So as the heads of the Hyperloop team at UT here, Gavin and I have had to answer this question more times than we can remember. And I'm sure obviously you have as well. But what is Hyperloop?
Hyperloop is a tube-based transportation system that allows you to go the speed of an aircraft with a fraction of the energy usage. It's fully electric, direct to destination, doesn't stop at every place along the way, and uses you guys are using something slightly different than we are, but uses new types of levitation, different types of propulsion. But ultimately, it's designed to save people time, move a mass amount of people, and allow people to live where they want to live and work where they want to work.
Yeah, so we do use air-bearing levitation. I know y'all are using maglev. What was kind of the decision process in that?
It was a lot of trade studies in the very early days, looking at the effectiveness of air bearings, looking at the energy consumption from air bearings, looking at inside of an almost vacuum tube where the air actually comes from, how much energy you need to put into that, And then ultimately some of like the manufacturing tolerances and the like. And so we did a couple of studies, we did a couple of experiments with some hardware that we developed and everything, and ultimately determined that we were going to do something different from a cost point of view and just from a constructability point of view.
Yeah, so can you kind of describe like different, because there's a bunch of different technologies in like these different Hyperloop companies. Can you kind of explain like what sets Virgin Hyperloop apart?
So we've done a lot of testing, a lot of, I'll say, development, and the things that really have set us apart are, one, the level of understanding and kind of empirical evidence that we have to go through this to make a lot of these design iterations. We've developed a new form of magnetic levitation over the last 3 years that's as energy efficient as steel wheel and steel rail, with no moving parts and no moving parts on the track, no moving parts in the vehicle, no active parts, meaning that the track is just passive steel, which makes it cheap. And so that was a big development, which is unique to what we've been able to do. We've also developed a new type of propulsion motor that's about 50% smaller. It's about 50% more what we call power dense, or has a higher power factor. And then ultimately is about 50% more efficient than other linear motors as well. So all of those things mean it's an extremely high performance machine that can go 800 kilometers an hour or 500, 600 miles an hour. And then we've made a lot of advancements on battery and power electronics technology, as well as controls development, to even consider putting everything on the vehicle. So we have a pod side system, meaning that the track and the tube is very dumb. There's no moving parts, no active parts. Everything's on the vehicle, which is pretty unique in the Hyperloop space to do this. And with that, it's been a lot of development of that, a lot of really pushing to make sure that this can actually be as energy efficient as we think it is. And the more and more we see EVs progressing, the better and better our system ends up getting, because we're taking advantage of all of those improvements in the field.
I'm just going to share a picture of the pod real quick. So you guys are using top down or top levitation, is that correct?
Yeah, so this is the vehicle that I actually rode in as the first Hyperloop passenger about 3 months ago. It's a good one. So Sarah's our director of passenger experience. So it's her and I in there. So it's good that we were the first two in. So that one was kind of the first generation technology. And about a week ago, we released the passenger experience video of, this is a 2-passenger vehicle. We're going to a 28-passenger vehicle. We looked at what that looks like, that has top levitation and some other features like that. So this is really the evolution of the design, where all the learnings that we've had from this have moved into the rest. And that's kind of the other piece to your original question, is we've actually developed a safe system. We developed a system that was independently verified by a third party to be safe. That's why I got in it. That's why Sarah got in it. Ann and Tanae did as well. So we've actually tested a passenger safe Hyperloop system and developed one, and taken all those learnings in the same way you experiment and test with on typical engineering things. We did that same thing with the passenger, the safety side of the fence. And that was really eye-opening for us as a company as we move forward.
So during your test run, was that a vacuum environment?
Yep. So it was about 100 pascals, or about 0.1% of an atmosphere, 200,000 feet of elevation, whatever you want to call it. So whole tube, and it's got up to about 107, 108 miles an hour. We are definitely the faster team of the two. So we ended up having that title for us, but it was in a full vacuum system. And it was everything that you want a Hyperloop: levitation, propulsion, control, vacuum. It was the real deal.
So you've talked about sort of like the paternal feeling of building a company. I'm wondering, in that moment when you were sitting in that pod, kind of what was that, not only the physical feeling of the pod, but what was that like emotional feeling?
It was pretty surreal. This idea of you're basically sitting in an idea, right? So 6 years before, this was a drawing on a whiteboard. we'd gone through quite a bit. They said you'd never be able to build a company doing Hyperloop. You'd never be able to raise money doing that. You'd never be able to make the technology work. You'd never be able to have a government say they would be a regulator. You'd never be able to make it safe. And like each one of those things we'd like knock down in the years that were like leading up to it. But it's different when you're like sitting in there, because at the same time you're sitting in there because of the team you built. You're sitting in an idea, team built it. You're trusting your team with basically your life, right? This is a new, experimental technology at the time, and we're making it safe. I'm sitting inside of it, and I'm an engineer. I know everything that could go wrong, but at the same time, you have to have a degree of trust that your team did all the right things. And yes, I've reviewed everything, but at the same time, you have to have a degree of trust. And that's why it was so interesting. Sarah, who is sitting next to me, she's not an engineer. And, we're sitting in there and we're talking while we're waiting for some stuff. And, I asked her, I said, at what speed would you feel, nervous, or what speed would you feel comfortable? And she's like, if we were, whatever speed we're going at, I assume it's safe, which is a really different point of view, right? Which is like, it's an awesome responsibility that she's projecting her own safety on my team's ability to do our jobs well. And that's a different type of feeling than, you really have. It's like all of a sudden this becomes like real. And one of the reasons I wanted to be the first person on it is because if it's not safe enough for me, it's not safe enough for anybody. And we didn't want to put test pilots on it. We didn't want to put, race car drivers on it, because ultimately, I want my grandma to ride on this. I don't want, only test or thrill seekers or adrenaline junkies riding on this. We need normal everyday people. And that's how our company becomes successful. So we had to design the system to handle that from the outset. So it was really exciting. I mean, you're kind of sitting there, it's going to work, but at the same time, you're humbled by the collective efforts of a team doing something that was told to you to be impossible. And there's been a lot of different moments like that where the team has come together and done something really amazing. But when you're sitting in there realizing you're sitting at, like the Wright brothers sitting in a plane for the first time, that it's like, would you know history if it was happening around you? And that's kind of what it really, really felt like.
So obviously looking towards the future of Hyperloop, what does the West Virginia Test Center mean for Virgin Hyperloop?
So we've done a lot of development, prototyping, putting all of that together. And what stands between us today and the system that we all can ride and any place all over the world is certification of the system. And so we did a mini version of that, really kind of a prototyping when we did the test a couple of weeks ago. But what the idea with the certification center is, now you need to go to higher speeds. You need to show a bunch of things. So you need to show that you can build this for the cost that you think you can. You need to, I'll say, operate the system for the cost you think you can. It needs to have multiple vehicles on the track. It needs to have, ways that people get on and off. And then ultimately, it needs to be able to do this for a long period of time. So all of those things kind of go into the certification process. So what the West Virginia Center is really the place to do that kind of at scale. So we would invite regulators from the US, from around the world, to come there to see the system, to operate the system. We'd have, operating hours, operating tests that would go into the actual certification campaign and the like. And so this is really the facility that stands between us and mass adoption of Hyperloop, is building, I'll say, this type of facility, getting the certification more specifically, and then being able to deploy Hyperloops around the world.
Oh, so I kind of want to go back to more of a technical question.
Yep.
We're finishing up writing a feasibility study, and I've been looking into like the safety and kind of more like how you get in and out. And what you realize is that it's more similar to a spacecraft since you're in this vacuum environment. And I'm wondering what your strategy is for getting getting customers in and out of the pod.
Getting patients.
I hope they're not patients.
Hopefully not patients, exactly. So we have a unique kind of view of how we're doing this, and we'll probably be releasing pretty soon the way that we're actually doing this, which is different than a lot of other people. But I'll kind of just give you the overview of the challenges. When you bring the vehicle in and out of the vacuum environment, it does a couple things. One, you have to pump that whole area down. That requires a lot of energy, right? And that could be, it could be time intensive. It could take quite a bit of energy to do that. And it's something that potentially could affect the economics of your system. And it's also slow, right? So that ability to have to take the vehicle out each and every time like that does take some time. So the way that we've kind of viewed this is we want to have pods come into the portal, which portals are what we call the stations. We want to have a pod come in. We want to be able to get people on, get people off, very, very quickly. And so, and using very little energy to do that. So we've developed a different way for the vehicle to interact with the portal or the dock in this case that allows substantially reduced energy consumption, much faster time, but also allows the vehicle to not have to be, pressure cycled each and every time that you get on and get off the vehicle. So we've worked on a pretty innovative solution on how to do that. But the key factor is, a plane, you can view it this way, a plane only makes money when it's in the air. So the longer it has to sit on the ground, the longer it takes to clean it, the longer it takes to board it, the longer it takes to maintain it. Any moment it's not flying, it's not making money. So that's what we're trying to do here. And that reduces the size of the fleet, increases the utilization, decreases the cost of the whole system. And that's really what we've developed is a pretty interesting, pretty exciting way to get on the vehicle without having to have all these, I'll say, challenges of actually taking the vehicle out each and every time.
So essentially your plan is just the door is essentially what's going to be the pressure seal on the pod?
Yeah.
So I also watched your new Hyperloop station concept video recently. And there are a lot of kind of different things in what you're doing right now with the XB2. One of them was I saw that you were kind of using like a top-based levitation system. So what does that kind of look like, and why is that something that you might move towards?
So it's substantially more energy efficient, substantially. It has much better controllability of the overall system, and it allows something that's really key. So if you look at kind of mass transportation around, let's just pick two of them. One is a railroad, and one is a car on a road. So on a railroad, anytime the vehicle wants to change tracks, something on the track has to move, right? So you have a switch, you have, in the case of conventional maglev, you have this big concrete I-beam that might move. You do a couple of things like that. For a road, if I told you every time a car went to get off at an exit ramp, the road needed to move, you'd think that's crazy, right? But that's exactly how trains work. And so if you want to have a high capacity system and you have parts that move on the track, you introduce a lot of potential for catastrophic failure, right? Like the switch can be left, right, or any place in between. And those any place in between could cause the vehicle to derail and everything like that. So what we wanted to do is have a high capacity system, because that's how, and by high capacity, like, 20, 30, 40,000 passengers per hour per direction. You can't do that if you've got things that have to move, because then you either only going to one destination, you can't go to multiple destinations, because then you have to rely on the vehicle, or in this case, the pod, communicating to the track, getting the signal back to make sure that the switch is in the right location. And then you have to have the time for the switch to move, right? So if everything's on the vehicle can, just like a car, can decide to go right or left. And to enable that to go right or left, if you think about it, you can't have any objects in the way. You have to be able to seamlessly move in kind of the two-dimensional space here. If you have something underneath, that becomes particularly challenging from an energy point of view, energy efficiency point of view. If you have something on the top, then you can kind of just move laterally, almost like a printer head or a whatever you want to call it. And that gives you the ability to have vehicles moving at high speeds, and then maybe a vehicle in the center of a convoy deciding it wants to get off, nothing has to really move, And it gives us a huge amount of flexibility to create systems that are like Hyperloops, but also to create systems that could benefit from what I'd say is energy efficient overhead levitation. And that's like moving packages around, that's moving cargo containers around, that's, all kinds of things that your mind can wander to.
So talking about cargo containers and such, Hyperloop has always kind of been more of a passenger centric vehicle concept. Where do you think like a freight Hyperloop might fit into this?
Freight is really an augmentation to this. So Hyperloop wouldn't be designed to move like rocks and ore and things like that. It would be designed to do kind of high value goods or perishables, whatever they might be. So like 2 examples for you. I'm in Los Angeles. It takes 4 days for a train to go from Los Angeles to Chicago. So you can't really put perishables on that unless you're in a special kind of refrigerated car or whatever it might be. The Hyperloop, you could do that journey in about 2 hours, right? And so you can kind of change what it is that you're able to ship. You can make, we can make something like a Hyperloop more relevant than a car or than a truck because of the speed it could go. So high value goods, things that are typically like air cargo or there. But the other thing that you could really do is you could just change the dynamic of shipping most things, because you do need to ship ore, you need to ship rocks, you need to ship corn and things like that. But lots of things are already packaged, right? And you want to ship those packages quite a bit. So our system can move about 3 or 4 tons of cargo at the speed of an aircraft for a fraction of the energy. The speed of the aircraft costs of the truck. But if you look at like the Silk Road in China going through Russia, they're spending about $100 billion to upgrade the average speed on that corridor from about 30 to 50 to 70 kilometers an hour. $100 billion they're going to spend on that, right? Hyperloop can go 10 times that speed. And so you start to see like, wow, if that starts to make a difference, now I can have vehicles going, tens of thousands of miles at, instead of 3 or 4 weeks, like it typically takes now, you can do that in 10 or 12 hours. And what does that mean for, just-in-time shipping, on-demand goods transport from distributed warehouses that like, oh, if I can get something in 12 hours, I could ship perishables, but I could also ship finished product without having to ship all these raw things and do inventory management and ports and all this other stuff. So it's a pretty profound way to think about, an on-demand society that we live in now, how to enable that and do it energy efficiently without destroying the environment around us.
So as a business person, I kind of want to rewind and ask a business question. My understanding is that this did not start as like a Virgin brand idea, right? So I'm wondering what made you decide that it would be a good partnership with Virgin, and like what makes Sir Richard such a good partner?
It's an interesting story. I left Virgin, and Richard had asked me at the time where I was going, and I said, I can't tell you. So, that was late 2014, and about 2.5 years later, 3 years later, they reached out, and Richard came to test site. So this was like May of 2017, and came out for the first time. And he was like, well, I see what you've been up to. And we started looking. And so it's really interesting, right? So what is Virgin kind of synonymous for? Well, they're for an experience, right? They're for a passenger experience. They're for a customer experience. They're for some type of experience. And Richard's kind of built his brand on adventures and the like. And so from like Virgin Hotels to, Virgin Voyages, which is their cruise ship, to Virgin Galactic now, which is the Virgin Orbit, like all about these kind of voyages. And even if you look at like Virgin Atlantic, right? So they don't make airplanes. They buy Boeing or Airbus airplanes, and they create the interior, they create the experience around the whole thing. And so for us, our business model is we want to build the technology, obviously. We want to provide a lot of the software that controls the vehicle and also the fleet. So you can kind of think of us as the technology that enables everything. But what I don't want to be is someone who's like cleaning the pods and putting making the interior and everything. I want to leave that custom, leave that flexible, leave that open to people who do it well. And so that's where Virgin becomes an operator, right? So they buy the pod, they buy the technology for a particular route. They put their interiors in it. They have their experience. They have a degree of whatever the app might be on the phone to get your ticket. They're curating the whole actual kind of passenger experience. And then they operate the system in that way. So they're kind of running our software, but they're choosing how to run it. In the same way they choose to set up flight schedules and what destinations to go to, they're starting to basically just use our software to create the experience they want for their customers. And, for a new type of technology, I think Virgin is a company that really enables, the thought of that, like, hey, we're pioneering, we're pushing kind of the forward here, and then sort of a really, really logical, really natural fit in a way.
So as CTO, I'm sure you always want to be working on the technical problems with Hyperloop, doing the engineering work. But as co-founder, you also need to make sure that y'all meet payroll every week and all the business side, the stuff that goes with it as well. How do you kind of split your time between those two?
Ooh, that's a good one. The deep down, the desire is really, I'm a technologist at heart. But the other aspects, right? Like if you want to see that technology succeed, you need to protect it, which means you need to build the business around it. You need to put moats up when you see things that could potentially hurt it. You need to go get it more resources. We're building something that's big, it's expensive to do the development, right? It's not like an app. This is a big piece of physical technology, and going and raising money for that, you're really out and you're selling people on two things. You're selling people on the vision, like this is what it could become. And you're also selling people on your ability to execute on that, right? Because investors invest in, C ideas, but A-level teams. And it's because they know what you have in your vision, what you have to do might not be how it turns out, because you learn and things need to evolve. And they're saying, like, do I trust you with my money to be able to figure those things out? So I'll say on average, and it fluctuates, it's probably about 50-50 in terms of the technology development, but sometimes it's like 90% technology, like really in the weeds for a couple of weeks and months to make sure things are going. And then sometimes it flips the complete other side, where I'm out traveling and talking to governments about regulation. I'm out talking to investors. I'm out talking to potential partners. But on average, it's about 50-50. So making sure that the technology is doing what the ultimate vision is, and you're being consistent and adhering to that vision, or you're adjusting the vision based on information that you learn. And then the other side is making sure that you can actually work on it and enable that. So it turns out to be about 50-50, which in conventional land is, CTO might not do so much external stuff, but we're also trying to convince people that this is going to work, and also that build an industry around the whole thing. So you have to kind of get out there and show the excitement, show the enthusiasm, but also back it up with more than just PowerPoint. Like, hey, this is a company that builds real hardware. Here it is.
So as CTO, there's probably no one better to explain the product. And you've been really successful at raising capital, over $400 million to date. So I'm wondering, how do you sort of sell and tell this idea, and what are some of the main pushbacks that you've had while trying to do this?
The main thing is really about two things. One, if you're selling an idea, if you're selling a vision, you have to get people excited about the vision, right? And so that's passion, that's exuberance, that's subject matter expertise, that's all of the things that says, like, if someone's gonna put their money into you versus infinite amount of other things, like, they're really kind of putting it into their belief in you, especially when I can't show them, like, here's my revenue today, right? I have to build the technology before I do this. So it's really about belief. It's about trust. It's about confidence in you and the team's ability to do that. So you're selling your experience. You're selling, now that we've had a company for about 6 years, it's a little bit easier than it was at the beginning, right? At the beginning, it's just, you got to trust me. You got to see my past history before starting this company, that I've delivered on things. But now, as I can show the last 6 years of progress, last 6 years of development and milestones that I've achieved here, and that gets people more comfortable with it. I think the harder questions that I get asked are really, they were definitely about the safety aspects, which we've really done a lot of good work with the test we did a couple of weeks ago to make that go away. The second is about timeline. And the third is, how much money do you actually need to finish the development? So, if a lot of investors are used to software companies or apps, which you could build a product in 6 months and you could deploy it and you could get, beta product and you get things going back. And we're doing things pretty fast, but it's still not 6 months, right? But you can compare us to like SpaceX or Blue Origin or even Virgin Galactic, and you can say those companies have all been around for 18 to 20 years now, and they're just getting to the spot where they're putting passengers on their system. And they're not like everyday passengers, they're astronauts. So we're trying to do a garage to grandma's in about 10 years, right? So we're on pace to do that, but that's a wildly different experience set. And so you're trying to convince them to do that. You're trying to get them going, and all they want is, you to do it faster and to spend less money while you're developing it. Two things that don't necessarily go hand in hand. But it's a bit of an education process, because there is, some concern that like, hey, this does need to be regulated. Regulation is a little bit outside of your control. How long will that take? Because if it's 2 years, it's one thing. If it's 20 years, I don't think most investors would do that. So you're kind of moving that along. That's why talking to the governments and everything is so important. But it's really trying to get people on board and comfortable with you and your abilities to, they know it's not me that does everything, but it's me that kind of inspires the team, pushes the team to ultimately deliver on what we're doing. And so that's really what they're betting on. And that personal connection is that, people that are putting large amounts of money into things want to know you, because if they know you, they know what makes you tick. They know if things get hard, if you'll bail, or if you're going to stick it through and see it out, because they're not going to be there on the day-to-day basis to watch how the money's being spent. So they have to trust and delegate it to you.
Yeah, it's a big trust factor. Virgin Hyperloop has a lot of domestic efforts, and they're eyeing a lot of domestic routes, but also there's a pretty big international effort. So I'm wondering where you think like the future of the immediate future of Virgin Hyperloop is, like geographically, and then what makes the ideal Hyperloop route.
So in the US, we do have a number of projects. Abroad, we have a couple of different areas. One is the India area. So India is really exciting because their infrastructure right now is saturated, right? There's over 1 billion people that live in India. It's going to be something like 300 million people that move into cities in India in the next 20 or 30 years. That's like the whole population of the US moving into like New York, Boston, DC, Philly, Los Angeles, and San Francisco, right? So it's a huge amount of people that are going to be moving. How are they going to provide them the infrastructure that's already at capacity? So we think there's somewhere between about 5,000 and 7,000 miles of Hyperloop you could build inside of India, connecting that whole nation. And they also want to invest in new technology. They want the connectivity that comes from it. But the amount of people actually makes it really interesting, because the ridership, the amount of revenue you can make from the tickets, is something that can be really attractive from private groups to finance. So it's not like it would need to be government sponsored in a way. You could actually sell these kind of private projects that could connect the whole region together, because there's so many demands. Like we're talking some routes like 200 million people a year would take it, which is pretty incredible. So that's one place. The other place is in the Middle East. There's starting to be a desire for more connectivity, because there's no connectivity now aside from really aircraft. And so if they're looking to move away from oil, move away from some of the things that have made the 20th century, they want to say, let's connect places together. Let's enable our citizens to travel more. but let's do it in a responsible way that creates jobs, that builds our infrastructure and the like. So inside the Gulf region and all those areas, you're looking probably somewhere between 3,000 and 5,000 miles of Hyperloop that you can build. And those two are probably in addition to some of the areas in the US, probably some of the most attractive places to go because they're the fastest places to go. And so what makes a good Hyperloop route is one that has a lot of passengers. What makes a good first Hyperloop route, one that has a lot of passengers, one that's not too long. So let's say about 100 miles or less. That way you can build it quicker. One that is, I'll say, in an area where there's not infrastructure already, meaning they're trying to connect something new and you're not having all the issues with the potential incumbent that you're trying to deal with. And then lastly, an area that has a lot of government support. So that's through regulation, that's through the ability to get the land, that's a whole host of these different pieces there. And that's why I think, in the India and the Middle East, those are some really good opportunities. In the US, I think areas that are connecting places that don't have the connection yet. Like one study was between like Missouri and Kansas City, right? There's a highway there, but you could connect those two. Instead of 3.5 hours, you can connect that in less than 30 minutes. It's nice, it's straight, goes along a highway median. And those are the type of things that I think are good, really good first projects.
So what do you think is the next step? Like, what's Virgin Hyperloop's next goal? Is it speed? Is it a different pod? What are y'all shooting for next?
It's really putting together, it's going from this 2-passenger to 28-passenger pod. Everybody talks about speed. We already know the technology can work at speed because we have lab rigs and simulations and a whole bunch of other things that show that this works. To show that at scale, that requires, miles of track. So we're confident that'll work, but that's also probably something that's also not immediately needed to demonstrate that everything could work. So we're really putting everything together into this 28-passenger vehicle as we go right now, getting ready to do some of the controls development, testing of that, of the production type of system. And then looking towards these certification centers and these kind of first projects to get them going. So it's more about taking everything that we've learned now, getting the regulation, the steps, the path to regulation in place, showing that this production vehicle works the way we think it does, and then ultimately going out and getting those projects.
I kind of have an industry question. Kind of more relating to the space industry, but where do you see like future public and private partnership, and what do you think are those different roles?
I think there's always such a fear for new technology causing jobs to go away, right? And there's always kind of this fear, like automation eliminates jobs and things like that. Whereas, 25 years ago, Amazon wasn't a thing, and Amazon is an internet retailer, and there's like 1.3 million people that work at Amazon. And this idea that technology provides it might close some opportunities, but actually provides new opportunities to do that. And I think the government's role is to make sure that regulations are not encumbering new technology development, not slowing it down. I also think there's a degree of need for governments to incentivize complex projects in a variety of forms, whether they be, subsidizing some projects, whether they be technology grants, whether they be development contracts, whatever they might be, because ultimately those things are going to progress the industry forward. So, for example, like in the Department of Defense, if they want to build a new aircraft, they give a multi-billion-dollar contract to a number of aerospace manufacturers, and they spend that on the development of it. The Department of Energy doesn't really do that. What they do is they incentivize either shared through like, hey, we'll give you 50% if you find the other 50% of private funds to develop like new solar technologies or new power technologies or whatever they might be, new nuclear technologies. And then they might actually subsidize the first builds of that, and the way they did for solar panels and the way they did for a bunch of these other things. So that attracts private investors. And what you saw that do over the last 10 years is you saw photovoltaic solar panels be one of the most expensive ways to make electricity. And now you see it's basically on par, if not cheaper, than a lot of other forms of electricity. And that was really done by the way that the Department of Energy subsidized the development of the idea. Transportation makes up about 30% of greenhouse gas emissions. And the Department of Transportation doesn't have the same type of mechanisms, right? They do have loans for projects and things like that, but they don't incentivize the development of new technologies in transportation. And so that's really, I think, an opportunity for us as we say, like, hey, we want sustainable transportation. We want green transportation, clean, whatever it might be, that they could start to look towards, like, maybe you don't subsidize the actual funding of this, right? But you create incentives for projects that use new technology in the same way that Department of Energy did. And like, I was fortunate enough at SpaceX, like when I started at SpaceX, the only reason SpaceX is still around today is because they got an award from NASA to send cargo to the space station. Without that award, SpaceX would have shut down, right? If you look at Tesla, Tesla got a loan from the Department of Energy to build the Fremont factory. Once they went public, they paid that loan back. So Tesla probably wouldn't be around in the same capacity today unless the government gave them the degree of support that they needed. And I think if you want big ideas, big projects, all of this easy stuff has already been done. So now that's all that's left is more complex systems, more complex products. Those take longer, they take more money to develop, they're more risky. And governments, I think, are in a better position to absorb that risk than the private side of the fence. But they don't need to do it alone. I think they can, if some degree of partnership with the private side, I think is the right, because it keeps the incentives right. I think the DoD methodology isn't the right way to go. I think that the DOE framework is.
So whenever you're talking about Hyperloop, safety always goes hand in hand with that. And there's probably a lot of kind of comment section engineers out there who think that there's some insurmountable kind of obstacles with that. What do you think is the most important thing for Virgin Hyperloop to prove to kind of sell the public on the safety of Hyperloop?
So we've shown that we can make a system safe in vacuum. That's what we did about 3 months ago when I got in it and my colleagues got in it. I think the only thing that's left at this point, in my opinion, is really the speed. So once we start going faster, are we able to, show that system is safe when we're going 600 miles an hour, like we've shown it's safe going 100 miles an hour? There's no reason to believe it won't be, but I think people will feel more comfortable once they see those speeds actually demonstrated. And the second piece is really showing the vehicles operating in convoys, because that's how we get the capacity. That's how how cost comes down, the economics go up. And in that case, those two things are really the two key pieces that we need to show from here. But otherwise, like, we've shown that people can actually be safely transported in a Hyperloop. It just was slower than our ultimate top speed.
So is the goal of the West Virginia Test Center to be able to reach the full potential speed of the Hyperloop, or is there still another step in between that?
It depends on how much length we actually get there, on the corridor and the like. It will be certainly a viable step. So some of the first projects that we're doing, you get the full benefit of 500 or 600 miles an hour when you're going hundreds of miles. Those most likely won't be the first projects that we build, right? The first projects might be 20 miles, 50 miles, maybe 100 miles, where you could show a top speed of maybe 300 or 400 miles an hour and be perfectly fine on those routes. So that's really kind of the target area for some of these certifications. Is like, let's get that speed dialed in, make sure we get everything certified there. And then as those projects get built out, then it's easier for us to go longer, to go faster, just pure time. We just need more length to be able to do it. So I think you'll see some of the first routes, you get up to those speeds, we'll demonstrate those at the certification facility, and then ultimately take them to an actual project and then just start running them faster and faster kind of Delta certifications or Delta qualifications of the technology.
I'm sure you don't really like this question, but as far as timeline, we're looking at human cert in 2023, I think. Is that right?
25. So we, based on what the governments are putting out now, we think that that's a pretty reasonable, pace for us to go through. Obviously, we'd love to do it sooner than that, but we think that it's kind of like realistic from the engagements that we've had in the US and in Europe with the regulators now.
Well, maybe the next time we have you on, we'll be inside of one of your tubes.
Oh, perfect.
Yeah, I'm from Dallas, live in Austin. That would make such a difference to have that route.
Yes, for sure. And I think it would be a heavily traveled route, that one. I know we've looked at a couple of other ones inside of Texas, but the Dallas Austin one has been definitely one that's been in the back of my mind as one to be, I think should be one of the higher ones. But that's my opinion.
Yeah, in my research,
I fully support that.
It's crazy just to see how many like supercommuters there are that travel 3 hours to work every day. There's something like 30,000 of them.
Wow.
Like this would be a huge game changer.
Sure.
Do you see this kind of changing the way where people live, kind of like the highway system kind of created suburbs outside of cities? Do you see that kind of playing the same way with Hyperloop?
I do.
Kind of just being able to live even farther from where you work, essentially.
I do. I think that you're going to be able to, there's this kind of idea, this notion called like the Marchetti constant, which is basically most people want to live but no more than about 45 minutes away from where they ultimately need to go for work. And so if you look at that, what that looks like in a city, if you look at that in kind of a normal geographic area, that sets sort of how far people live away from work. I will say that Hyperloop being at the speeds it can, now all of a sudden I could actually live in New York and get to Washington, D.C. faster than I could get across uptown Manhattan. That's a different type of dynamic. And I could live in one area, I could work in another. And you really have that flexibility to, your super commuter, your 3 hour commuter, as you mentioned, Gavin, like that now all of a sudden now can be someone that's actually like a 3 hour super commuter could be someone who works in Los Angeles and lives in Chicago, right? And like that could be the super commuter now, instead of someone who lives in like Orange County trying to get to Los Angeles. And so that's the opportunity to really be there. It also gives people the flexibility to I think to have a different type of lifestyle. I love being outside, I love cycling. I could live near Yosemite, but I could come in every day and still have a normal type of commute without all of the hassle that I see here.
Well, I think we've taken enough of your time, Josh. I want to thank you so much for coming on. We had a really good time, and it was really cool to be able to talk to like someone who is pursuing what we really enjoy at the largest scale. So it was really cool for us.
Beautiful. Thanks for having me, David and Gavin.